Alright, so I expect this to be somewhat short, just like previous ones. So yeah, where were we? Get status. Oh, yeah, I still have to add a remote, but yeah. I think this one I won't do public, to be honest. I think I'll probably keep this one private. Like, the Connect 4 stuff will be public, but this one is like kind of... Well, we will see for now. Who knows? But anyways. Okay, so what were we doing last? Some GameState stuff. Basically everything is GameState. That's like a very fundamental entity. Like, to define a game, you just have to basically like one of the main things is like the game state, and then like how to transition from two states. That is like the move or the action. So yeah, game state, right? Okay, actually no, wait. Let me like reverse search my past these. Yeah, exactly. This is my canonical V, right? I mean, my like, sorry about that. Like, I want to kind of like open up this game state, which is what I'm working on for the BumperCoin bot repository. Then the game state for BC for BumperCoins, like the actual like the BumperCoins, like what I want to create a bot for, and game state for CF, which I've successfully trained using AlphaZero. So like game state CF is kind of like the model, and I have to take our current game state and like kind of like whatever methods, whatever like services that the game state CF provides, I have to mirror that in the game state while still being compatible with like some stuff from BumperCoins. Like for example, like whatever code in BumperCoins that relies in game state, particularly at least I believe the physics engine, like it needs to kind of like conform to the same APIs that physics engine expects it to. So yeah, it's kind of like a hybrid between all of these both. So anyways, that's why like this is like my main V. Anyways, skip to a C4, like Connect 4 CF. You can see at the bottom. So anyway, so like we have a constructor, which I think I was doing last time, right? Like just giving it a like some default like initial variables. I was kind of like modeling this existing bots, except I decided like rather than having the coin fall on a midline, well, whereas like if you fall on the midline, subjected to rounding rules would kind of like make this coin land here and this one land there. Oops, I pressed play. Sorry about that. Pause. Exactly. So like I just kind of like snapped everything to center of each square. No big deal. Snap means they end in 0.5s. Okay, so constructor I think is done. Again, like nothing is truly done. Like we don't know, but it looks done to me. I mean, again, we have to like we're just kind of like, never mind. Yeah, I think it's done. Well, anyways, the point is I'm moving past it. So then we have we have the constructor, game status. I think I did that too, the previous stream. This refresh thing, I don't know. This is a remnant from BumperCoins. I do think it makes sense to actually shift this in physics engine, but anyways, I'm not sure. Never mind. But the point is, so get game status is also done. I think yeah. So I did this like recently too, and these were anyway. So that's those two. So we have done constructor, and we have done wait, what? Right, so we have done this one, and now we're on apply move. So I see there's a get legal moves, and there is an apply move, and there's a clone. So apply move, again, like, now I was thinking, okay, so move is a very, I mean, there's discretization there too, but for now, let's just assume that like, yeah, let's just assume that where we want to do apply move. So what does apply move do? In C4, it just like, well, first of all, like it checks whose turn it is. So there's like that error check, and then there is what is this block doing? Row. Oh yeah, it's looking at the top row, and then while r is less than the number of iterating or r, and this dot cells of the move is empty. Alright, so this is like kind of like looking at all, like it's starting from the top and going down, like kind of skipping past all. It's trying to find the moment at which the cells stop becoming vacant. Right, so now we're kind of like that. And of course, if the whole thing is filled up, or wait, no, if it's wait. Wait, how is it? Wait, what? R is less than 0? Oh, okay, so this happens. So this basically is because of that, like, we kind of like, this means the column is fully full, like, it's completely full. Like, that means, like, this whole thing, like, this, in particular, this expression right here, like, this evaluates to false when it's completely filled up, which means we kind of, like, do R minus minus, so from 0 we're at -1, and we cannot, like, add something in the -1th row. It's not like some languages where you wrap around. Like, no, this is just a problem. So that's kind of like how that's why. So yeah, okay, that makes sense. And then what do? We just like kind of change a vacant cell to a like which P1, P2 owned, and we toggle the turn. So that's how apply move works. Okay, so let's just kind of copy these, the signature of that, and start doing it, right? Apply move. And let's see how the other one does it, right? How does apply move work for GameState? I mean for C4. You have a constructor right here. You have, I don't think it has it. Refresh is game over. Same thing as outcome. Wait, no, never mind. Not outcome. Game status. So this we've already get coins for player. Oh, okay. So in like the existing code, GameState does not have any it does not have this method apply move to it. Okay, which means we have to cd into our BumperCoins repo. Or actually, let me just BumperCoins. So then how would the move actually be applied, right? Well, the client would send the move to the game server. So let's cd into game server. And the game server, let's look at the files here. There's a game manager. I think that's for like server, and game manager are mostly for routing it, but like the core gameplay, like the core logic is inside this game directory. So let's go into that. What else do we have here? Move manager and game. Well, I think it's move manager. Oh yeah. Actually, there is a to-do where I should merge this, fold this file into game.ts. Because initially what I was doing is like, you know how like in like, well, Lichess only gives you like a 1 move pre-move, but like chess.com you can pre-move like what, up to like maybe 10 pre-moves or something? Or like some number. I think it's 10, I'm not sure, but you can just make a whole bunch of like pre-moves. And I had like a move queue where you could kind of queue up a bunch of moves and like cancel them. But because of the energy system, I ended up like kind of like changing, deleting that. But I may bring it back. So I think having 2 files there's some merit to that. But anyways, the point is that I guess move manager, I'm guessing the code I'm looking for apply moves lies in this file, right? Yes, handle move. To have this return the adjusted move and velocity components that are applied. Okay, this looks like a big deal. Return the adjusted move actually the thing is for handle move, to be honest, like we don't have to do any, like I know like this does a bunch of like adjustments and validations, like clamping logic and stuff, but actually maybe I'm leaking this code. Maybe I don't want people to like look at this and like kind of, oh wait, there is an apply move. Okay, yeah, let's pretend that no one saw anything. I mean, I don't think there's any, I mean, there's nothing like kind of, I hope there's nothing like, there's nothing that people can like see this and like kind of exploit stuff. But the whole point is I'm saying like there are a bunch of checks that are done here, like these like kind of greater than, like if you're kind of like taking a move that costs more than what we currently have, like we're doing some like scaling down in proportion and all that. And like if we're kind of like trying to launch a move which is greater than the max velocity, that means we're kind of like they're trying to cheat, or they're trying to like kind of, well, I shouldn't say cheat, I'm not sure that, but like if it's egregious, like anyways, but the point is that like there's some like kind of checks here, right? But in the terms of bot versus bot, like when you're like kind of doing like just machine like the AlphaZero algorithm to like self-train these things, like we can assume that they're playing fairly, right? Like it's all internal, like we're not like sanitizing like user input and stuff. So in fact, this whole handle move is basically a wrapper around like it's doing some like kind of sanity checks and stuff and like some adjustments. But ultimately, like here's what, like I mean, again, like it's not that they're cheating, like there could be some desync between like the client and the server or whatever, like if they have a laggy connection. But like things may change server side and client may think it's different. So like the point is that like it's all wrapper for this. So here's the actual apply move. So okay, okay. Why the hell is there a return? So in this thing, you're returning a move and a fixed point, where like the move is the actual like. So I don't think apply move is a void in terms of C4. We just kind of apply the move, it changes the state of the game. Whereas here, like it's returning some stuff, and this stuff is used to actually like for the replay. Like the replay basically kind of returns the move itself, and it returns like the energy it consumed. Like with these two numbers, the replay system can like faithfully execute or do the replay. Now, I don't think that this is technically needed. I'm not sure why I have this. Why is returning a fixed point? Like kind of deduce that, like maybe anyways, the point is, wait, what is the point? The point is there's lots of like extra code, and like we can probably like hone in on like what we like really need from this, right? So apply move takes in a coin, a VX and a VY. But like the VX and VY and the VX and VY and the coin ID and this coin ID are all actually components of move. So like apply move just takes in the move, like that's it. The energy cost. And we know the energy cost, right? The energy cost is like 60 or 59.2, but we're gonna just make it 60. Right? Or 59 point whatever. I know I did the math in like some previous streams. Yeah, we're just gonna hard code this stuff. So what does apply move do? It just looks at all the coins. It just searches all the coins for the given player, and then instead of return undefined, it should throw an error. But anyways, but again, I'm not gonna throw an error in like the point is that this bot project is separate from the actual game, the live game. So anyway, so it iterates over the coins. Once it finds a match on the ID, it does some multiplication, like some multiplier in case like the king coin basically gets some buff, like it launches with a bit extra velocity, some more like OOMPH to it. So anyways, like it just like kind of scales everything by the multiplier, both X and Y components, and then it subtracts the energy cost from the energy, and then it just subtracts it from the energy for the respective player, of course. Now, I guess in here we don't actually have to worry about energy costs. Like we don't have to care about that entirely. Like we're just forgetting that the energy system exists. Like we're just treating it as a turn-based game. So any of these considerations, like energy costs, like we don't have to even like deal with them entirely. Like we're just, I know it's 60, but like instead we're just like advancing 30 ticks per each player's moves, which has a side effect of between two moves of the given player. That's kind of 60 ticks. So it replenishes the move. So like the math works out. Like we're not cheating. Like it's playing fairly. It's not like kind of, it's not it's abiding by the rules. Like it's not cheating basically. So yeah, cheating is bad. So okay, yeah, this is basically it. Like we just like get the VX and the VY. We kind of like do the multiplier from it, and then we just kind of add it to the coin, and that's it. No energy nonsense. And we simulate advance by 30 ticks. So okay, let's just do that. Or let me just actually do a V so for less of that. Let me just kind of go there. Do v GameState.ts and like that. Or actually, let me also open up. the GameState for CF too for reference. Search for apply move. Center it on this line. Okay. This is move manager. Let's go to the bottom of this file to or actually I can just do the same thing there. Apply move. Okay, center that line. Apply move, and then go back to here. Apply move. So let's first copy this. This is from C4. Because if it's not the person's turn, then we have a problem, right? So apply move, just it's a void return type. Okay, good. If the move that is for P1 is not equal to this dot P1 turn, error message should not see this message. It is not this player's turn yet. Okay, that's fair enough. Okay, now I think this is an error because there is no is for P1 a notion on the move. I think it's on the coin. So so let's actually save that and quit out of here, and then let's just do a v GameState.ts, and let's open up coin.ts, and let's open up move.ts. Just a fundamental. Wait, what? We don't have a move. Okay, so let's actually, we have to like do a bunch of CPs. So like CP BumperCoins shared move.ts to move.ts here. Status. Now we have a new move.ts. Okay, let's look at this move. Or let's just do a git add move.ts status. Okay, now let's actually look at our move.ts file. Very simple. All move.ts is it takes in the coin ID, the VX and the VY, the velocity components, specifying the velocity, and it has a coin ID. Much like the move in C4 has the, instead of coin ID, it has the column ID or the column index, right? They're both like kind of the similar things. So okay. So now let's kind of do what I was trying to do earlier. The V of the instead of CF, let's open up move.ts and search for apply move in this file. Center it. Let's kind of go to the next file. Search for apply move. Center this line. Okay, so apply move, like, well, yeah, well, let's first get the coin, right? Coins, and for a new error. Unable to execute move. Wait, no, this seems stupid. Let's just do that. Let's just copy these two lines. Just comment this block in. This is a C4 reference. Unable to find coin. Unable to find coin. Unable to find coin specified by move in GameState. It's a good message. Okay. So once we're in this if case, here's like our main thing, right? Here's what we mainly have to do. We found the coin. Then if wait, no, wait, hold on. Okay, so that's that. And then if the coin dot actually wait, let's coin dot actually have to quit this. Let's open up GameState and let's open up coin.ts as well. So coin is P1. It's not is for P1. It's coin dot is P1. That's the thing I was looking for. Coin dot is P1. So if coin dot is P1 is not equal to the this dot, wait, no, not coin of coins, this dot coins, right? This dot coins, yeah, we're not, yeah, coins and is P1 turn. Actually, let's just copy that. And something like this. But instead of that error message, is actually this one, right? Okay, so we can delete this comment. So what this line should be doing is, so let's just say that like the coin, let's say that the move specifies a coin who's player 1, right? So that means our move is trying to launch a player 1's coin. But let's say that is player 1 turn, it's not player 1's turn. Like let's say that right here, let's say that the move is trying to launch a coin, player 1 coin, but it's player 2's turn. That's illegal. So if coin.is_P1 is true, but then it's not player 1's turn, so this one is false, then true is not equal to false, so we should throw an error. And the error should say that, should not see this message, it is not this player's turn yet. Exactly. Oh, that's fancy. Should not see this message. In fact, I like that. Let's just kind of bring that in there too. No, never mind. Forget it. Yeah, never mind. So yeah, so that's that. So once we're outside this if, once we reach here, that means that we found a coin to launch, And the coin that we're trying to launch is indeed like legally launchable in that, like, first of all, this coin exists, it's not being removed, and it's not being refreshed. Remember, refresh basically removes these coins, like it splices them out. Oh wait, oh, what am I doing? I'm in insert mode, not in a... Let's just, that's a known save point. Okay. So we should not see this message at the player's turn yet. So let's say that it is player one's turn, so this is true, and the coin is for player one. That means that it's player one's turn, we're trying to launch a player one coin. So that's consistent. So that's good. We're on the same page. Now let's see how we do this, right? Very simple. We just look at a pie move. Let's do it from the end of the file, because like there's a bunch of other instances of it, so we want to like search the last one, so we kind of reverse search from the end, censor that. So pie move, basically we found the coin, kind of copy this line, the velocity multiplier, I like how the indentation is already there, perfect. Then we get the we do it for the VX. We do it for the we set it. Then we're gonna do it for the VY. Save that. So now we've set it, and that's it, right? And no, I mean, that's not it. There's a bit more. This whole energy business, no, what we do then is we advance it. Let me actually put this in the shared constants. Never mind. Then we want to advance it, right? So then what's that called? Like, okay, physics. To do advance GameState by 30 ticks using physics. Now physics I actually don't want to leak, to be honest, because physics code is like kind of like the magic sauce, a little bit like the secret stuff. Like I may do this off stream, but like yeah, that's actually kind of why I don't want to like if there are glitches or certain things like that I don't want to like be released yet to anyone until I know it's like bulletproof. Like physics, my physics code in physics.ts, I've been very intentional on avoiding showing its contents. But yeah, like the main API, I think I'll do it off stream, but it's called like physics to update game state. I have to kind of like copy, like call that in a loop, basically physics to update game state. That's kind of the compatibility. So I may do it off stream, but yeah. And also put 30, or rather 60 over 2, 60. Or instead of that, let's be fancy and do bit shifts, right? Or sorry, that's not divided by 2. This is divided by 2, right? In some constants file, or like put 0.4 and do the mults and divs to get it. Do the whole whiteboard stuff. Actually, no, forget it. Or 30 in shared constants. Basically, shared constants can like kind of be everything, maybe. Well, just put it somewhere. It doesn't really matter. But anyways, so just advance it. That's it. Okay, let's see how this compiles. Claire, actually, let's first do a git diff, cause like I was like kind of like doing some undos, or I was unintentionally. I thought I was in in a escape or like not an insert mode, but I was in insert mode. I was actually like mucking around and like my commands were kind of like, yeah, I was kind of like dirtying the file. So let's just make sure that the diff makes sense. So yeah, the diff pretty clean. All we did is like kind of, we didn't like mess around with other stuff in GameState. We only modified one file, GameState. And our B version, or our new version, like we just only added a new apply move. And this one, like it searches over all the coins. And then if it doesn't even find any, oh wait, no, sorry, we have to return. Okay, that's a huge bug. Yeah, we have to return because like with the moment we found the coin, we actually apply the move, we change the game state, and then we have to return out of it. Get diff. Yeah, this is all I should add return. So apply move, like we search, like this whole loop like loops through all the coins, and it eventually returns. But if we haven't, like if we're still out of this loop, that means we weren't able to find the coin specified. So like that's a problem, and then we just unceremoniously terminate the program. But here, we search through everything and then we eventually find it, and we make sure that like the coins, like the coin belongs to the player whose turn it is. So like if it doesn't, then we just kind of again unceremoniously exit. And then now that like it's all good, we found the coin that we want to launch. We look at the move, and we wait. Wait. Where the hell is VX defined, right? Move.vx, move.vy. Okay, yeah, let's do that. Yeah. Yeah, we have VX and VY. They're part of the VX and VY are part of the move. Just like that. Basically stuck in the move dot in it. Okay, that looks good. Okay, so I'm not going to explain everything. We're just going to resume from where we left off. We find the coin's a king coin, and we get a bit of a buff to it, multiplier, or else it's just one. We multiply it, and then we just kind of do the same thing component-wise to each component. That which we do to X, we do to Y. So VX, VY are now updated. And this to-do I may do off stream, just so I don't want to leak the contents of physics. Or, well, actually, well, anyways, I just want to, we delete an empty line. And then we just, we just add the new apply move. And then there's still a bit of a to-do to actually, like let the game state unfold a bit. But yeah, that's the crux, that's kind of like the overall gist of it. So now let's see if this compiles. Cannot find name move. Okay, fair enough. You just have to import that. Just copy this line. Get diff. Yep, we just added the import thing. Line 83. So here's the fending line. Oh, move that coin ID, right? Just to make sure move that coin ID is a thing. Yeah, move that coin ID. Okay, good. And there are no errors, right? Yep, no errors. Compile doesn't gracefully exit. Okay. Get status. Get add all. Get diff staged. We already saw this chain set, and we look at that. We just introduce a new move. Very straightforward class. It's just very compact. It's a Pojo, plain old Java object, I guess. P-O, and then J to JS. Pojo, Podso. Specifies the coin ID, like the column index analogous in C4, and then gives it the actual velocities. Okay, that's fair enough. Get status. Get clear. Get status. Get commit. Some work on GameState dot apply move status. Okay, yeah, I think that's all for now. I'm gonna just head outside before it becomes too dark. Well, yep, pretty short again because I feel like lately, ever since I've done Connect 4, like the C4 stuff, I've kind of like, I feel like the interest, like I feel like now that like Alpha Zero, like it works, like I have a proof of, like I have like an actual like Connect 4 website that like has a decent bot. I kind of feel like I'm kind of done in a sense, and like this Connect, like this BumperCoin stuff is like not really stimulating. It's just like boilerplate, just like glue code, like gluing together these two different repositories. And like, I mean, the Monte Carlo tree search with like the recursive search definition, that was like the fun part. The other fun part, I guess, TensorFlow like does for us. So it's like, I don't know, I feel like I've done like most of the work already, and like this just feels like kind of dragging on, you know. It just like, it feels a bit wasteful. So it kind of like, yeah, like I guess it's a bit boring. But anyways, yeah, that's all